Hey students, I have some good news and some bad news. I'm going to start with the bad news first. Sadly, Kyla woke up with a cold this morning. Pretty bad cold, a lot of coughing, sneezing, but she didn't have a fever, but now she does have a fever. So I'm not going to be at school on Friday. Sorry. Um, so I thought what I'd do is I'd go ahead and make a second video. This video could be watched on Thursday, or it could be watched over the weekend. I recommend just watching it on Thursday, getting ahead, and then on, this will basically get us set up for Monday. So we'll just have a big work day basically tomorrow and Monday to get caught up with everything. And remember everybody, tomorrow's a big quiz week, so you really want to get caught up with all these lessons and on this homework by the end of this weekend, so that next week when we're going bam, bam, bam with those quizzes, you're not spending hours and hours studying for these quizzes, that you're prepped, and you're prepped because you have good practice. So the first lesson I did earlier today, and this is on Thursday, I gave you a graph and you had to write out the equation for the parent function. In hindsight, maybe I should have done this lesson first, and this lesson is graphing parent functions. Now, if you know the parent function and you know the function transformations from that function transformation worksheet that we did, you just got to combine those two ideas together and you're going to be graphing parent functions. So you might not need this lesson because, like I said, if you combine the parent function lesson along with a function transformation graphing lesson, that's essentially what this lesson is right here. I'm going to graph two functions for you. The first function I'd like to graph today is y equals 3 plus the square root of a negative, that's a negative in there, x plus 4 divided by 5. You might want to think about inside outside. I'm noticing inside the equation, which is inside is stuff that's going to affect the x values. I have this negative, so that is a let's see, that if it's affecting the x, that is a y-axis reflection. The divided by 5, as we've talked about before, that represents a horizontal dilation by a factor of 5. And this x plus 4 shows that we are going left 4. So on my x, y coordinates, you apply the reflection and the dilation first. So it would be a negative 5x. And then after that, you include the left 4. And if you're going left 4, you're actually going to subtract 4 from the coordinates. So negative 5x plus 4. Those were inside. Outside the equation, and these are things that are going to affect the y. The only thing I have is this plus 3, so we have an up 3, which means that you're going to take the y values and add 3 to them. I'm on Team Non-Graph Paper, so the next thing I do is I apply these rules to the 3 points that are in a square root graph. There's 0, 0, there's 1, 1, and there's 4, 2. Sorry, I'm kind of running out of room here. Negative 5 times 0 is 0, minus 4 is negative 4, 0 plus 3 is 3. 1, negative 5 times 1 is negative 5, minus 4 is negative 9, 1 plus 3 is 4. And last, negative 5 times 4 is negative 20. Negative 20 minus 4 is negative 24. Enjoy that, team graph paper. And let's see, 2 plus 3 is 5. So I have a graph, and let's see, with an x-axis reflection, think about how the graph is going to look, team non-graph paper. If you're team graph paper, you just graph these 3 points and you're done. Just connect the dots, the arrow, your starting point, and you're good to go. But if you're team non-graph paper, you need to think, how does this graph look? And with the y-axis reflection, that means that the graph's going to look like this. And then you just put those 3 coordinates in there. It started at -4, 3. This next point was -9, 4, which would mean this third point is -24, 5. Definitely not drawn to scale, but because these numbers are exact, I personally don't think the graph needs to be in scale. It just needs to have that right look. And I think that's the right look because it's pointing in the right direction. Alright, that's example 1. I recommend trying out example 2 on your own. It's an x squared graph. You've got a, let's see, 1, 2, 3. There's 4 transformations in this one. That makes it a quiz or a test-worthy problem. Try it out on your own. I'm going to take a 15-second break and then I'm going to start solving it. But I recommend you pause it, see if you can solve it on your own, and then re-go. So 15 seconds, go. Uh-oh, looks like we have some students coming in. Alright, here we go. Inside the function. Hello, I'm making a video right now. That's actually what's happening. It's alright. So inside the function is this x minus 3, which demonstrates that we are going right 3. That's it. That's the only thing that's going on inside the function. So as far as the xy coordinate goes, if you're going to be traveling right 3, that means you take that x coordinate and you'd add 3 to it. Outside the function. Outside the function is dealing with the y coordinates. I have a negative first on the outside in front of this the 4, which is a dilation, but this negative, because it's being multiplied by the function, that shows an x-axis reflection. The 4 is a vertical dilation by a factor of 4. And then this 2, it's a positive 2, and it's being added or subtracted to the function. I guess because it's positive 2, it's being added to the function, so it shows that it goes up 2. Alright, so first you apply the reflection and the dilation to this, so it would be negative 4y, and then because of the up 2, plus 2. Now, let's see. X squared. This is an x squared graph, so there's 5 key points that you need to worry about. There's -2, 4, -1, 1. There's 0, 0. There's 1, 1, and 2, 4. And if I apply these values, I always start with 0, 0. 0 plus 3, 0 plus 2. That's 3, 2. The 1, 1. 1 plus 3 is 4, the 2, 4, 2 plus 3 is 5. If we just keep doing this with all these x values. -1 plus 3 is 2, -2 plus 3 is 1, check it out, 1, 2, 3, 4, 5, that makes sense. And then 4. 4 times -4 is -16, -16 plus 2 is -14. 2, or 1, -4 times 1 is -4, -4 plus 2 is -2. 1, -4 times 1 is -4 plus 2 is -2, and that should match this number here. So I should get a -14 with this last one. 4 times -4 is -16, -16 plus 2 is -14. Alright, so those are my 5 key points, and this is a negative x squared graph, that x-axis reflection. So that means that instead of this graph pointing up like it normally does, it's going to point down. The vertex point is this 0, 0, 1, which is 3, 2. Then this one would have to be the 4 point, which would be 4, -2. 5, negative 14, 2, negative 2, and then finally 1, negative 14. And that would be a quadratic equation. And I didn't do an absolute value equation for you, but an absolute value equation would essentially work out the same way. You want to know what? If you want an absolute value equation, you should pay attention, and let's do an absolute value equation. If you feel confident at this point, I don't think you'll need this anymore. You probably just go ahead and hit pause and move on with your life. But if you want to see an absolute value equation, here comes one more. Let's say that I had y equals, so let's go with, I'm trying to think of what I want to do with this one. Let's go with negative 3 absolute value. On the numerator would be x, I don't know, plus 3. And on the denominator we'd have a 4. I'm going to change this to a 5 so that each number is a little bit different. Okay, inside, outside. Inside, affecting the x, I have this divide by 4, so it's a dilation, a horizontal dilation. Horizontal dilation by a factor of 4. The x plus 5 means it's going left 5. So as far as the x coordinate goes, the horizontal dilation shows a 4x, and then after that, if you're going to go left 5, you're going to subtract 5 from those x coordinates. Outside the function, I just need to check. Have I been writing? Yes, horizontal dilation. Okay, I was worried I wasn't writing the word horizontal or vertical. Outside the function, I have this 3 that's being multiplied by the functions. That is a vertical dilation by a factor of 3. And the negative on the outside shows an x-axis reflection. So, x-axis reflection, vertical dilation by a factor of 3. That means that you're going to be multiplying that y-coordinate by negative 3. And then there's no up or down or anything, so there's nothing to add or subtract from it. Okay, now we're going to apply this rule to our 5 key points, negative 2, 2, negative 1, 1, 0, 0, 1, 1, and 2, 2. I'm going to use a couple shortcuts here, speed up the process. I always like to start off with my 0, 0 point. 0 minus 5 is negative 5, and negative 3 times 0 is just 0. This doesn't look like a 0 here. 1, 1. 4 times 1 is 4. Minus 5 is negative 1. Negative 3 times 1 is negative 3. 2, 2. Let's see, 8 minus 5, so 4 times 2 is 8. 8 minus 5 is 3. And this negative 3y, 2 times negative 3 is negative 6. Now, this looks like a V, right? Because this equation looks like a V, I can kind of do a little bit of a shortcut here. Because of the V or the upside down V, I know that these two coordinates here and here, they should have the same y coordinate. So if this y coordinate's negative 3, this y coordinate should be negative 3. If this y coordinate's negative 6, this one should be negative 6. Furthermore, I noticed that from this point to, well, these points over here, they're always differing by a distance of 1. So whatever these x coordinates are differing by, it should be consistent. From 3 to negative 1, that's a distance of 4. From negative 1 to 5, that's a distance of 4. So you just keep going a distance of 4. Another 4 would be a negative 9. Another 4 after that would be a negative 13. All right. The only reflection this one had was an x-axis reflection. So instead of being an a right side up V. It's going to be an upside down V. You should be using a straight edge. Yeah, we should be using a straight edge. Let's get a straight edge. Let's do this right. Make my vertex point, and I know it's going to be just an upside down V, so I'm going to put that with an arrow, and over here, that with an arrow. Look how professional that straight edge line looks. And now we have a point at -5, 0, a point at -1, -3, another point at 3, -6, and then on the other side, -9, -3, and lastly, -13, -6. Okay, and that is writing or drawing graphs of our parent functions. Everybody, I hope you have yourselves a fantastic weekend. I'm sure that what you saw on Friday was that I gave you 3 different worksheets of practice. I'm not expecting you to solve every single one of those problems. That's way too much, but it's good practice material. So just, pick and choose what do you need to practice, what do you need to get better at, and work on those worksheets. I'm going to have absolutely nothing new on Tuesday. Is that right? I might have something new on Tuesday, but I'd rather just have Tuesday just be a work day. We'll find out. Anyway, the calendar I keep on my website would give you a definitive answer, but I think we're just going to have Tuesday be a work day, catch-up day, and then Wednesday, Thursday, Friday start getting ready for that. We just have one more topic to learn after this lesson. So just one more lesson this unit. Yay! And you still have a test in 10 days. So plenty of time to get caught up, plenty of time to prepare for this test. I hope you have yourself a wonderful weekend, everybody. And there's that cold going around right now. So take care of yourself, and if you get sick, stay home. I'll see you later, everybody. Bye-bye.